Today I'm gonna talk a bit about what we've been up to in the last year. This does not include any from the 2020 year where there was no ClueCon. So if you want to catch up with what's been going on with OpenSIPS in 2020, I guess you just have to read the release notes. But this year we've been working on Diameter, and we have actually quite a bit to play with already in the 3.2 release. I'm going to split the talk in 3 parts, where I'm going to talk about protocols to get everyone acquainted with them. So it would be weird to talk about them and not know what we're talking about in the first place. The second part, see how we integrated them, what libraries we used, and what end product we built. And for this last part, dive a bit into IMS and see what the roadmap we have over there. I guess my introduction was already made. I've been doing this VoIP thing for almost 10 years now and split my time between the open source and side of things and our consulting company. And Radius, first and foremost, which is the predecessor to Diameter, was first released in 1997, so like over 20 years old. And it was designed to be a AAA protocol. AAA sounds fancy and all, but it just relates to authenticating users or maybe devices, right? It doesn't have to be a person behind it. So making sure they have the right credentials. Then once they're authenticated, do they have the right permission, right? Because you may know the password, but you have 0 rights, so that's not good for anything. So that is authorization. And finally, log all of those operations that they are doing. So that is the accounting side of things. This is what it looks like. You can even compare it to HTTP to some degree, in that there's a request and then there's a response. It's a very simple transaction. That is how all Radius requests look like. And speaking of what they look like, this is a packet capture. And you can see this is the big chunk of the message, right? Where you see AVP, AVP, AVP. It's just a bunch of AVPs, really. Username, status type, whatnot. And the topmost headers tell you what you're actually looking at, what type of request it is, right? What kind of identifier it has. Okay, so that is enough about Radius. No point in talking about it too much. But then 6 years passed, right? So we're now in 2003, and Radius has been deployed to production on all sorts of companies and levels and infrastructures and purposes and applications. And they've been starting to notice some issues with it. So they already were thinking about coming up with a next generation Radius, because what they've initially imagined to be a solid protocol had all kinds of loopholes and missing definitions, and you had to improvise in all sorts of places. And also, they made a clever naming pun, right? Because you have a radius, and if you double it, boom, you get the diameter, right? So what did Diameter bring to the table? First, it stabilized a bit the documentation on how to fail over, it introduced procedures for failing over to the next agent, whether if it's Diameter or even Radius, because they are backwards compatible with each other. Moreover, it took care of reliability of the messages, because Radius was designed to use UDP, and it turned out that there was a need to use a protocol which offers better guarantees. And speaking of transport, diameter mandates TLS. So there is also a security aspect here. So that is the mandatory way to deploy it, or rather, if you follow the specification, you have your diameter implementation has to have TLS support. And then, of course, they define the concept of proxy, redirect, relays, so you don't have to kind of come up with them on your own. Back in the radius days, you kind of have to do that. And also, they introduced the idea of negotiating capabilities. So all of a sudden, diameter nodes have certain advertise their capabilities and can negotiate whether they would need to peer or not, right? Because if your software requires a certain capability, it shouldn't peer with a node that does not have it. And speaking of exchanges, this is the kind of a low-level overview on how it works. First, it all starts with a connection establishment request, CER, right? And the reply is a CA, a connection establishment answer. And there we go. There is peering between them. And then they will continuously, or rather periodically, send device watchdog requests. And the device watchdog answer comes back. So that means they are still alive, both of them. And in order to end the session, they send a disconnect peer request, the DPR and the DPA. And that is pretty much the backbone of the protocol. And on this foundation, you can build all kinds of message exchanging scenarios. And speaking about the higher level, that is entirely compatible with what we had before. So let's take a look at the packet. This time it's a diameter packet. Guess what? It's the same AVP, AVP, AVP from top to bottom in the body. And maybe they added a couple of headers here towards the top, like optional, but it could be the flags. I'm not sure the Radius had this, the flags header, but nevertheless, diameter, definitely a diameter agent will support a Radius packet, but the vice versa is also true. Even if you have an older device on your network that is running Radius and you start upgrading some others to diameter, they will work together. And about these AVPs, they are of three types. Maybe I'll go quicker on this. So you have the fixed ones, such as session ID, which must be towards the top of the message. Actually, it must be the first one in the message. And then there are either mandatory or optional ones, depending on how you want to tweak or fine-tune your diameter application. Maybe you don't even need all of them, right? Then why implement it if there is no need for them? And as far as what data they can hold strings, either 4-byte or 8-byte integers, or there's this group AVP, which is particularly interesting in that it can hold other AVPs. So it is you can achieve this kind of nested structure of AVPs, which may be quite useful in some applications. Maybe you have a variable amount of AVPs, right? So rather you group them into a grouped AVP, and there you go, you have the structure. There are also header bits in the diameter packet. One of them signifies that whether if it's a request or a reply, whether if it's proxyable, and whether there was an error or not. And also AVP level bits. I won't bug you with those too much. And I've highlighted some applications for diameter that we've implemented in the OpenSIPS release with regards to the bigger picture of all. I mean, this is not, of course, all the diameter applications. I guess there are maybe a lot more of those. But let's say just the first page, just to give you an idea for how small the SIP world in relation to diameter is, because there is much more to diameter than just SIP applications, right? You have credit control, NAS, and all sorts of other ones, quality of service, and so on. Also, with regards to the plethora of reply codes, we've only, the ones I've highlighted here are the ones that we use in the current release, but of course there are many more others, and all of them are fully documented on this great registry by the IANA, which is actually one of the few resources where you can read about this stuff. There is not many other sites that give you these ones. So if you're doing a radius or diameter, you've probably known about this until now. If not, make sure to take notes because it's really useful. All right, so that is all about the protocol side of things. Let's get into the FreeDiameter integration. And so we rather than taking all of this and starting to implement all of this work, we found the FreeDiameter project, which looked great, and moreover they even mentioned that it is useful, or rather it is catered to either research or if you want to build a network operator. So that sounded great. So it means it has some stability. And looking at some statistics for the project, it goes way back to 2009. It is written in C, so quite stable. Of course, you can see that it has been, activity has dwindled a bit lately, but this is an update from actually a couple months ago, where they announced that they've moved to GitHub. So it's not by any means dead. It is, development is still going on, but rather I expect that it is quite mature and there's not much stuff to be done, right? How they've done a great job so far. There is, looking on the webs, there is some literature around it. There are guides on how to write extensions. There are all kinds of presentations from them. Some guy did a Docker file, right? So you can build containers with FreeDiameter. The API is fully documented. And here is an extract from their mailing list when they announced it at the IETF. So they're involved even in the engineering, the working groups on that part. And this is an interesting one. Notice that actually the OMEC, which is a big conglomerate of organizations, including Google, Intel, AT&T, whatnot, they decided to use FreeDiameter in this project they had, where maybe they showcased how you can enable 5G with open source, because I noticed they forked it on GitHub. That fork didn't, not much happened to it after it, right? There was only a few commits, but it's interesting to see that they used it. So if you're building a diameter implementation, there are kind of three layers you need to take care of, right? There is the peer layer, which is the lowest level one that we've been talking. On top of it, you have the message parsing logic, right? Have to extract the information, the AVPs and whatnot. And once you have all of that, right, the question is what to do with it. So the parser won't solve that for you. You have to build the application on top of it. So with regards to the bottom two ones, they are perfectly covered by the FreeDiameter project. In fact, they nicely package it into this FreeDiameter Proto library and FreeDiameter Core library, which take care of each layer. And there is packaging available for these, but only on the more recent operating systems. So you will only get it starting with Debian 10 or Ubuntu 20. So good to know. The library is quite comprehensive. You have primitives to build all kinds of objects and how to route or dispatch the diameter packets. So this is on the protocol side of things. But on a lower level, there is also another header file which allows you to configure, manage, and full control over peers, again, endpoints, initialization of the application, as well as a way to customize the configuration of it. So maybe you want to build, or rather to tweak the FreeDiameter configuration file and add a couple of your own parameters or stuff like that. There is a way to do that as well. And how it ended up looking on our side of things, we have the AAA.H interface, which had already been implemented on the radio side of things, right? We've been having this since 2009. Using the Radius client library, and now we have the AAA-Diameter module fully decoupled, no impact on Radius, nothing broke or something like that, which makes use of these packages. So this is the client side of things, right? This is the OpenSIPS that will connect to FreeDiameter, but we had to build some logic in there as well. And they also did a good job on the server side, and they allow you to build these modules that they neatly organize them, whether if it's a logic or an app with a lot of logic, or whether if it's for debugging or just a dictionary of AVPs, such as this one, or for routing purposes. And if you can find this OpenSIPS application in the modules AAA-Diameter directory. Of course, this is new, and therein lies the Diameter app. Of course, it's a bit counterintuitive because you will grab the source code and compile it in the FreeDiameter project, right? So as soon as this stabilizes a bit, the code here, we will for sure make a pull request on the FreeDiameter side of things so that we get this merged, because it will be much more nice. Not only it will be nicer to manage it over there, but also it will get picked up by the packaging, right? So that will be awesome, that you won't have to build this by hand, as you kind of have to do now in this, it's the starting phase of things. A quick look at the configuration of the Diameter daemon, and you can see what I was saying earlier, that they make you set up TLS. Even if you look below, we are connecting to the client Diameter test peer with no TLS, right? So I can view the packets and develop quicker. They still make me install a cert and the key and the certificate chain, just because that is how the specification asks, right? That was quite nice, I think. And also we load 2 extensions. One of them is the SIP dictionary with all kinds of useful SIP AVPs, and one with the app OpenSIPS, which is the app we just compiled. So it acts as a server and receiving all the messages from the OpenSIPS side. A quick shout out to all the people at FreeDiameter, which is pretty much led by Sebastian Degugy. They did an excellent job maintaining this project and bringing it to the state where it is today. Very thankful to them. And here is how the applications shaped up in OpenSIPS. This is how the routing happens. Because if you don't know up until now, OpenSIPS is a multi-process application. And so it is capable of processing high throughputs of SIP traffic, right? Thanks to all of these workers which are using up your CPU cores in parallel. And we have one of these processes will also act as, will specifically act as the FreeDiameter peer. And from there on, it forks. This is all part of the library initialization sequence, where it forks a few threads which will do all the work. Some of them listen for incoming packets. So this will be the replies coming in. And one of the threads will keep track of all the queued messages that will be sent out. So this is a bit quick image on how it works. And let's see what we build on top. First of all, this is the Digest Authentication app. And here we have the client and the app OpenSIPS acting as the server, and they exchange a simple multimedia authentication request and the multimedia authentication answer. And that is how you authenticate a phone maybe that submits a password and it gets validated on the FreeDiameter D side of things, right? Because we're doing this over diameter. Maybe a quick look on how the packet looks like. There is the essential information, right? We need the username, the domain, and the nonce that has been generated, and over on the server side, and the response that was computed. So OpenSIPS computes this using the user submitted password, and on the server side, it will compare and make sure they match. And on success, this is what the reply looks like. If everything goes okay, you'll get a 2006, which is the diameter success message. That is how they made it, and that is how the authentication works using diameter. Second app we built is the accounting, and similarly, there will be ACR and ACA exchange, which stands for accounting request. So not much difference over there. If we look at the message, it looks a bit different because when you're accounting, you have to include a lot of information, such as duration of the call, setup time, whatnot, right? The trunk that was used, the outbound gateway, maybe you have costs or other types of fields, and all of this can be customized. Here, it's interesting that Wireshark, it does not recognize these types of AVPs, right? Because they are custom. So it says implementation specific. But I guess I'm not sure. That is for another day, whether how easy it is to tell Wireshark how to read your AVPs, which, by the way, you can fully customize and define in this dictionary OpenSIPS file. This is what we had before with the Radius, and it is also the same file structure is compatible with the diameter module. So that's as far as what we've built so far in this initial release with diameter. But let's take a look at what is ahead of us, because now that we have this diameter peering support, we can start looking into IMS and building IMS agents and services and network functions and all of that. But first of all, what is IMS? I guess I have like 5 minutes to talk about all this, and then we can jump into questions. Shortly, it is a standardized way of looking at, of building a VoIP infrastructure. So to me, it is a bit, so if you think about it, all of us are specialists at building these VoIP platforms, right? We are good with SIP signaling, we understand media, we can identify all of these components of a platform that are required for it to work well. But every time we build a new platform, we kind of slightly reinvent the wheel, or rather, going from developer to developer, we call each component differently or have our own way of doing things. And pretty much this is what IMS solves. It offers a kind of a generic structure of building a VoIP platform with each component being labeled and having its own name and purpose. And if you put all of them together, there you go, you have a fully capable VoIP service. So this is one image I found. Rather, this one, I think it's more readable. And you can see all of these abbreviations like HSS, SLF, ICSCF, PCSCF, SCSCF, MRFC, MRFP, NGFCF, and SGV, right? What the heck is all of this? And how am I going to learn all of this, given that I've been used to a different mindset all of this time? But it turns out that there is a full correspondence between a working platform that we are designing and delivering, right? And it is working, right? Because everybody's happy, all the sides. And an IMS platform. For example, let's take them each one by one. HSS, right? Sounds funky, but it is actually the home subscriber server, which is nothing other than an OpenSIPS with a subscriber table. That is all. It is just a bunch of subscribers and their properties. SLF, location function for the subscribers. Well, that is the user location module, which pretty much locates a registered user and can send it off to the server it registered on. PCSCF, proxy call session control function, that is just a SIP proxy. That is right. OpenSIPS that is what it's best at, the SIP proxy, or rather was best at. I guess nowadays it's known to be best at kind of a different set of things. SCSCF, serving call session control function. This is the SIP. It's again a SIP service, but it is an OpenSIP server with more brains into it. So it is kind of the core of your business logic. ICSCF, the interrogating call session control function. This is a component that sits in front of the serving and kind of balances to them. So that is, we have that with the dispatcher and load balancer modules, right? Application server, this is the one that sits on top and interacts with the clients and so on and so forth. This one can act as maybe it is a back-to-back, so you can use the back-to-back module to achieve this one. MRFC, the MRFC and FP, these go together, and this is the media relay, right? The processor. This is your RTP proxies or RTP engines, and that take the streams and relay them to the endpoints. And the controller is nothing more than the RTP proxy control port, where you start the session, you end the session, you manage it, maybe change some things to it during the call. BGCF, that is a breakout. So this is when, this is just shortly, just a derouting module. This is how you route by prefix and you choose the lowest prefix cost and whatnot. So all of these are things that we already have. So it is just a matter of building these services and tying them up with Diameter, or sorry, not building them, rather just repacking them and saying okay, now I have a PCSCF, right? And but of course, there are some things still missing, which is the ability to build custom Diameter messages. So this is one of the first steps we still need to take before we can move forward with the IMS. So the ability to give the developers the ability to build these very custom messages, because if you notice, we've been working with those MAR and ACR requests, which are just kind of static. This would allow everyone to build these messages and build whatever Diameter-based product they want. And once things get going and certain of a good amount of these logics become repeatable, and we feel that we could help developers by packing some of these requests into a module, then maybe we could begin writing these whatever IMS functions that may be popular and packing them as IMS modules. So kind of that was it. There are quite a few resources on this topic. There is a blog post, there is module documentation, and there is a big tutorial on how you can build the app OpenSIPS and how you can integrate it with FreeDiameter. And yes, this is our roadmap ahead to start entering the IMS side of things. And for this, we need you. So let us know, now that we've taken the first step to bring you Diameter, let us know how you would see your ideal IMS integration look like, right? Like, what are some components that would be useful to you, so we can put them on the roadmap as well. Let me know if you have any questions, and thank you for your attention.